Welcome back to Cool Club's headquarters here in Scottsdale. Today we're having a bit of fun, and then we've got some serious tech talk at the end of it, I guess. So we're here with our CEO and founder, Mark Timms, and we're going to be partnering up today. Mark and Kim Brayley from KBS Golf are going to tell us a little bit about their story, and then some technical detail about golf shafts and the history of golf shafts and the future of golf shafts, hopefully. So let's just get straight in, and whoever wants to start, go for it. How did you meet? Tell us some fun stories about that.
I'll give you a fill-in real quick. I met Kim because obviously I had a store in Connecticut, started in 1990, and booked a time to go up and visit the factory. And I got Kim to show me around, which is the first time I met him, and wandered around and saw this ancient factory, as you would think of it today, with heavy machinery and stuff. And we got to talking a bit, and I guess we had a couple of drinks at the bar or whatever, and then 6 months later, he started doing these certifications for rifles, so frequency matching, and how you did that, and how you built them from blanks and stuff. And me and a couple other guys were the first group that ever did that. And then from them, we spent a couple of days together, and that's how it started.
Yeah, well, I was the guy that would give tours, and Mark, I find out that I need to give a tour with this guy named Mark from
Custom Golf in Connecticut.
Custom Golf in Connecticut, and I knew about Custom Golf. I was at that point in time. I talked to a lot of the club makers, so I was aware of them. I had never met Mark or talked with him, but anyway, so I get a call that Mark's here, and my office was actually in the main building, so I come down, and this factory is it's turn of the century, the last one, and these are huge brick buildings, and it was an entire city block and some. We had to ride a bike around. I mean, it was a big place, and you had to park in specific spots and things like that. So, and we'd go through the gates and all that. And Mark decided he wanted to park right in front of the main building. So I come and visit this guy, and there's a little race car sitting in front of the in front of the main building, and there Mark was.
Probably making some noise as well. The car was a little loud.
So anyway, that's how I first met Mark. He was the guy parked in front of the building with this little race car.
He jumped the security gate, I believe.
Yeah, the security guy knew he was coming, but he didn't tell him to park there. I can guarantee it. But in Connecticut, between where he lived and our factory was up in the northwest corner, and it was kind of a hilly, mountainous area, and it was really good for driving.
Yeah, I had a lot of fun driving around up there.
So. You're a BMW fan, right?
Yeah, I was a BMW fan at the time, eventually race cars for a while, and so we've been in a couple of cars.
that was set up for racing.
Oh, yeah.
That's pretty fun. So then you get this tour of this factory, and you're already, well into custom golf industry. Yeah. But you hadn't experienced, frequency matching, or
no, I noticed it a bit. A good friend of ours that we both knew, this guy Jim Laudenschlager, had a driving range across the street from the school I went to school with, playing golf and stuff. So eventually, it kind of linked in that way. But
here's another story. Me and Jimmy actually we were on the same golf team and at the club level. His family joined our club a little bit later. I think I was probably about 16 by then. And anyway, Jimmy was a year older, and he went to Jacksonville. And later, come to find out that Mark actually worked for him. Yep. He had a driving range.
Yeah, driving range at school. Yeah.
And so anyway,
that's how we got kind of connected.
Yeah.
So he knew Jimmy forever, and I'd heard about Kim, obviously, and when we started the store up, frequency matching stuff. I had a frequency machine that we got from them, and so Kim told me how to use it.
And that was your first time experience. Like, how did it work? And
right.
Yeah.
Well, the plant tour takes quite a while. I mean, this is a huge thing, and I usually would save the last part of it for we called it the FM areas, where we did the frequency match, and that's where all the machines were set up, and that's where we did all of that, and that was Mark is he loves machines, so
yes, he
does. The factory's amazing. I mean, to think that once you see everything that's involved, to be able to make something as cheaply as we were able to make it is pretty amazing.
Yep.
And but then again, Custom Golf was a premier high-end shop, and once Mark saw the frequency matching thing, it just it made a lot of sense to him. It wasn't really hard to explain to him, but anyway, by then of course we were full bore. We had been Precision at that time. We were purchased by Brunswick, and I had been working with it for about 8 years by then. So anyway, in terms of all the technology and everything, it was already in place.
What golf shafts were you producing at that time? The original rifle?
Yeah, well, no, the rifle shaft came along just a little bit after that.
Right.
We were still doing the Precision shaft, the FM shaft.
Right, okay. So give us a little bit, there's some technical stuff. What was the Precision shaft, kind of how was it born in terms of, how did you physically produce that golf shaft?
Okay, well, initially we worked on the tour, and that shaft, the very first one we designed was 130 grams. Guess what? I mean, that's what everybody was playing. So in terms of stiffness, it was very close to what the guys were used to. I had nothing to work off of when my dad invented frequency matching, and basically he told me to figure out how to make it work, and so I immediately went to the library. That's the way we used to do research back then, and there was nothing. There was absolutely nothing on steel golf shafts. There was quite a bit on Hickory.
Yeah.
But there was absolutely, and this is the University of Pennsylvania. This is a really a good library.
Yeah.
But anyway, I'm not sure how I got on this one, but there just wasn't anything to in terms of research. It was everything was handed down. There was never. It was stuff that club makers would hand down to another club maker or their son or whoever.
Just kind of did it because you did it before, and it sort of worked.
Yeah,
Tribal knowledge to some extent.
It very much so. It was totally empirical. I mean, there wasn't a lot of, there were no standards, and which there
barely any today.
Yeah, barely any today. And but anyway, getting back to the initial shaft was designed around a stiffness that the players were used to.
And you didn't manipulate weight at all there? You managed to change stiffness without changing weight?
No, well, when you're starting out with something, what do? You pretty much got to go where they're at.
Yeah.
And that's what we did. In terms of the weight and stiffness, we started doing things with stiffness in terms of really understanding that all shafts, all S shafts aren't created equally.
Yeah.
And back then it was probably worse than it is today.
Yeah, it could be.
But that's what we did. We were precision shaft, and what we were able to do was actually we got a system that was based off of 43 inches. If the shaft club oscillated, and you guys know how this works, and right. Basically you put the butt end of the club in a fixture, load it, let it go, and it counts how fast the shaft is moving. The faster the shaft moves, the stiffer the shaft is. And, obviously what we would do is we would take these things, having the ability to be able to measure and group the S's within the S.
Yeah.
We were able to come out with much more, the sets were just, in terms of the finished product, it was just.
You could guarantee that they were as close as possible.
Yes, yeah. We eventually we knew where the finished product would be, knowing what the head was and knowing what the overall length was. But
so go back to, you touched on it just a tiny bit. It was Hickory. So you both have played with Hickory, and I know you still tinker with Hickory today, right? Yep. And Mark's pretty successful at playing with Hickory. Yeah. What did you both know about Hickory golf shafts? Had that influenced, your decision on the golf clubs and things going forward?
I didn't know anything, to be honest with you. I mean, this last couple of years when I started playing Hickory was the first time I'd ever used them. And interestingly enough, we actually stuck some, because Tad Moore, a good buddy of ours, does it. We actually put them in an S3 machine and measured the frequency and torque and all that stuff. And it's pretty bizarre, actually. So the shafts I play in Hickory are like 7.0 on a frequency machine, but they're like 16 degrees torque. Right. And if you plug all that math into the software we got, it actually comes up correct, because there's so much more torque than there is anything. But
so that's my strong and heavy,
and they were pretty consistent, And Tad Moore now today actually sands them down and actually looks at frequency and gets them the right stiffness. So it was kind of more of an art back then. You actually sanded them and wiggled them and tried to match them. So
you still changed your diameter. It's still tapered down. And
there was an old club maker in Philadelphia, George Izett. He was a Scottish guy, and he came into our plant. He used to come to our office and when we were still outside of Philly, and you know, he said that we took the art away. You know, he felt that you know, what they did with the shaft was an art.
Yeah.
And they did. What they would do is that they would go through a series of things. They'd start with glass and they would end up with steel wool. But what they'd do is they would shave it and shake it and shave it and shake it until it felt
Pliable.
whatever it was that they were looking for. And he was good at it. And anyway, so when we came along doing all the things that we were doing, he felt that we had taken the art of making a golf club away.
Yeah.
I mean, FM Precision to start with actually was the first kind of, you know, system and stuff to come out with saying, okay, we've got you 8 shafts that match. I mean, not the same frequency, but they go on a slope and they all combine together. Because, you know, years before that, obviously on tour, the tour players would just, you know, shake one or whatever. And I think it was Hogan that had like 8 different brands in his clubs, but all the shafts actually kind of matched. They'd feel them.
Yeah, yeah.
So his dad was kind of in the way of actually putting math to matching these clubs like this guy was doing with shaving down the graphite.
Yeah.
And that's kind of where we're at now, right? So we still kind of use that scale, 10 different flexes of stiff, because you know, there's a lot of different stiffs.
And you're literally in the process of reinventing it.
Reinventing that a little bit. Yeah, because things have changed, right? You can do a lot more with graphite than you could with steel. Steel is relatively easy to figure out on a frequency machine. You know, it's you know, it's a homogeneous material. It's all the same material, so you can change the diameter and you can change the wall thicknesses.
That's right.
And that's about it. Graphite, there's all kinds of other options that do different things to the shaft.
Well, I'd love to talk about that a little bit because you both probably had seen factories and you produce graphite, right, Kim? So Hickory, the reason why it's got so much torque is because wood grows in a grain and it all grows in the same direction, right? So therefore it can really twist.
That's right. The Hickory goes up in a 0 degree axis, which is
great for stiffness, but torsionally it can spin a lot.
So you know, it's interesting that wood goes at a 0 degree axis also, and it's very, very stiff, but it has hardly any. It has some torsional resistance, but very, very little.
Yeah.
You can literally take one of these Hickory clubs and you can twist it easily. You know.
And you can see it somewhat in a golf club when it's torquey. You can kind of feel it twisting, but nowhere near like that. Yeah. So then what do you do with graphite to reduce torque, for instance?
You put more 45-degree angle plies down.
So you're laying carbon strips, pre-pegs at different angles.
Yes, yeah. Carbon fiber only has strength in the direction the fiber is laying. So 0 degrees would be maximum stiffness.
Yeah.
45 degrees would be maximum torsional stiffness.
And what about in the 90-degree plane as such? If you were going direct, like a wrap around the golf shaft, would that have
That's
any?
what we're talking about, at 0. Right?
Yeah. Okay.
So you're
stiffness.
running up and
if you go round, obviously, it's torsional strength.
Right. Okay. So it's the same.
If you're putting a thread, you know, the grain down the shaft, you make bending strength. So.
Yes.
Okay, I missed that one, but Mark sounds like you got it.
Yeah. And then steel's completely different, right? So like you say,
steel's a homogeneous material. It has equal strength in all directions, and I believe that for different applications, different things are going to work better. For the amount of weight a steel shaft is carrying at that length, steel's a fantastic option. You can maintain the swing weights at the lengths that you need without any problems. And when graphite came along, they found that you can make your drivers longer. And
what were your original driver lengths, you guys?
43 inches.
43 was the standard. I mean, everything was 43 for years. And it's crept up and crept up over
And that's
time.
because materials that you're inputting in the heads are changing, so you can basically...
The head's got bigger, so you got more room to hit it, and the shaft's got lighter, so you can make it longer and swing it faster.
Yeah, woods were the size that they were because of the material that they were using. You know, that's the size that was best for them swinging. You know, somewhere along the lines.
The size was just dictated by the weight.
Yep.
You can only make it so big because it weighs X.
Right, and now we got 3D printers and AI computers, and we can make stuff big and light, and Okay. Touch on we spoke about like the original shafts, like Dynamic and Propel. They were about 130 grams. And you had an interesting sentence. You said to me that it was basically the most effective way from getting a 0.600 down to 0.355 or 0.370 of an inch.
Yeah, these were, when I worked with Brunswick, and these are manufacturing outfits, and of course they made a lot of things prior to making golf shafts. But anyway, when eventually they got into golf shafts, that was the pattern that was out there. The people at Union claimed that they came out with it first, and the people at True Temper claimed they came out with it first. But True Temper's was called a dynamic, Union's was called a propel, and it was the exact same shaft. So, but the dynamic was they were a marketing company. Union wasn't. So the dynamic became the really popular shaft. At one time, Brunswick purchased McGregor, and that created some problems within the industry. I'm not sure what Brunswick was thinking, but all of a sudden the propel was at McGregor, and the dynamic was at everybody else's, and that's one of the reasons why the dynamic is as popular as it is.
Continues today. Yeah.
Got it, right.
And I'm assuming you were selling all of these products at your facility.
Yeah, that was a little later than us, but yeah, we started off with FM precision shafts. Actually, I remember getting them in college with Jim, and I played 7.7 high kicks, which I couldn't even bend right now. So
yeah,
that's gone away, and so it was 3 blown discs from trying to use those things for a long period of time. But yeah, I was from super stiff, and obviously, as I get older, we go lighter and lighter, and now I'm in 90-gram graphite of his. So
yeah.
He's got a set in VIPs, a really nice looking set over in his office that have 7.3s in them. So he must have been a little bit weaker. And that was a really cool thing. And that was one of the things that Mark loved, was the fact that we could actually put a number on something.
Right.
Yeah.
So 7 was an X, right? But there wasn't just one X. There was 7.1, 7.2, 7.3.
Yeah. At that point in time, we did.
Yep, they made
if we could do it, we did it.
That's a lot of SKUs.
Yeah, oh yeah.
Yeah. I was young, and I just thought, having the ability to do all those things was very interesting to me.
Yeah, and it still rings true in our software today. We
still
break
do
flex down at our high end level to such a fine, based off of your same system, I guess. How did you evolve? Basically these people are making tubes, steel tubes. And you've looked at this, and over the years, you figured out, what did you figure out that you needed to change, wanted to change to produce something different?
Well, I mean, like I said, it was an open book. I mean, there was nothing nothing written in the damn thing. I mean, I don't know. Everything's changed. What we thought initially was head and shoulders above what was thought prior to that, but I mean, we've learned so much since then that it's kind of hard to say. What is the, what are the things that are the, an order of magnitude or anything like that. It's just.
Do you have any key beliefs that you think?
Yeah,
this has to go into a golf shaft?
There's some formulas that I use when I design golf shafts that I know makes things more efficient, and I tend to do. I have things that I do, and I stay within my box almost entirely.
Graphite, steel, the whole works.
Yes, absolutely.
Without giving away your industry secret, what can you let us into there?
It's
Anything?
just an energy transfer thing, and the shafts that I design, people tend, regardless of how much you may dislike me, my shafts feel good, and anyway. One of the reasons why the shaft feels good is because it's it has a lot to do with the design, and once you have a set of match clubs, it's actually easier over a period of time to be able to strike them more consistently, because you're not having to make any kind of changes that better players make without even knowing they're making those changes.
Yeah. Just quickly, maybe you could explain. I think this would be a good thing for people to understand too. Is obviously way back when you started, you went from all 130 gram shafts, and you made them stiffer and weaker by mostly the diameter, right?
Yes.
So these long things. You trim the tip, which is the soft part, it would get stiffer. You trim the butt, which is the stiff part, it would get softer. And that's how they kind of fine tune it. But all the blanks are about the same. So over time and stuff, obviously we've made, looked at lighter materials, and there's all kinds of weird stuff that happens, and a lot of it is math, right? So as you just get lighter steel shafts, they just get softer. But in graphite and some other things, there's all kinds of other things that go on with the shaft, like where it bends. So EI comes into point, or kick point, or whatever you want to call that, how the stiffness is distributed. So it's got a lot more complex, and you've gotten much better at using that. But if you could just explain just kind of what the difference is, and how you go from, I guess, what your stiffest shaft would be, which would be a C taper 135 that you made for Jason Day, to like the lightest, KB 90, and how you progress in the middle from that.
Okay, well,
so as you go from the heavy, how do you start making it softer and lighter?
Yeah.
What are the keys to doing that?
I've never designed a golf shaft in my life that wasn't designed for something. I had a target. I've never done anything. I've never been a throw the stuff on the wall kind of guy. I've always had a target, and working with frequency right off the get go, that's what I used to measure it. What was your question?
Well, so when you go lighter and you get shafts softer and stuff, you obviously make them lighter now. Yeah. You also change the step patterns and stuff to do things to make them go higher and stuff. So
all those things were going lighter was it's just
natural
natural.
Step, right? Yeah.
I mean that's just the way it was going to go. Through what we learned with the frequency thing. By then there were not just two shafts. I mean we're talking. This is in the 1980. Everybody had proprietary shafts by then, so there were quite a few shafts available when you were doing what you were doing. But I would bet that when you were fitting people, which you were actually fitting people back then. You probably were using TT lights.
There was probably 2 or 3 steel shafts. That was it. We used TT lights as our lightweight steel. We used FM with the regular one, and we used dynamic golds as another option. Yeah. And that was really it. Yeah. We did some micro tapers. We did a lot with the original one, which is basically a soft tip shaft that got up in the air, which was great for a lot of people, and that's what most shafts are now, actually.
And that was a shaft that we designed, and that was a shaft that we learned something. That was a step down pattern that I had done quite a few years earlier when we were having a breakage problem with some ultra lightweight featherweight stuff. And what that step is, I called it a deca step because it was 5 times longer than a regular step, but it ended up being called a micro step. And what that step is, it's actually a step's a weak spot. Every step is a weak spot, and transitioning it over an area that's 5 times greater makes it much more stable and less likely to break. And originally, that step was designed to specifically.
So it's basically more steps and smaller.
Well, if you remember, we just did them at the very top because that's where the breakage was.
Right.
And it was something my dad invented, and we were making really light golf shafts. This is like in probably
90-ish,
93, something like that. But anyway, we've been all over the map. What we considered to be a lightweight shaft 15 years ago is much lighter today.
Yeah. Touch on Mark kind of said there, like, so C taper being your strongest, and a lot of people, they see C taper, feel C taper. It's weird. There's no step pattern on the outside visible. It feels matte finish versus most steel shafts. That chrome. So give us if you can, give us any insight into why that is that way, and a KB90 is stepped and chrome and all those kind of things.
Okay, well, like I said previously, everything I do, I try to, there's a reason for it, and it's all about fitting, and it always has been. I mean, for me, it was about fitting. When I didn't even realize it when I was, designing. Somebody needs a 7.3. I had no idea that I was fitting somebody. I was just chopping a shaft off to make it. Right. You know what I mean? I had no idea, but in hindsight, even way back then, the stuff I was doing was about fitting. And the S taper is a shaft that fits a category. The original shaft I did with KBS was the KBS Tour. That's the shaft that's going to fit the majority of people. I mean, you could fit almost everybody into that shaft.
That was really a start of your success really with KB, right?
Yes, absolutely.
You came out with a shaft that didn't have a reinforced tip.
Yep.
Felt better because of that to some extent.
Well, the reinforced tip, the biggest advantage of the reinforced tip was being able to get a little bit longer golf club without going up in swing weight.
Right.
So in terms of fitting, it gave the fitter the ability to go a little bit longer. And I mean, it was like 2.5 swing weights or 2 swing weights for a half an inch, but that's something. And and that was that was something that we thought up until that point in time. Even myself, I thought a steel shaft had to have a reinforced tip. And the reason why I thought it had to have a reinforced tip is because that's what I was always told. And I never bothered to do any tests to find out that you really need that. I just, again, it was one of these things that every shaft I had designed up prior to being working with FST, every single shaft I ever designed that wasn't a wood had a reinforced tip. And again, because I thought they had to.
And what do you do there? You just place more material down in that section?
No, it happens to be about heat treating. We were utilizing heat treating. You got to understand, our factory, the factory that True Tipper uses today, these factories were built around the turn of the last century. I mean, they made a lot of parts for the Second World War. They made all kinds of, it was during that age. And, over a period of time, although, like at one time, our factory made skates, but over a period of time, they somewhere along the line in the late 20s or in the 30s actually, they started to get more involved in making golf shafts, and in the 40s, they actually, it was in the late 40s is when they really got involved in selling golf shafts, selling steel golf shafts. But anyway.
But then you started with, FST, right? And they had different machines and stuff, so you got to do different things.
Well,
right?
yeah, and the heat treating came along to the point where it wasn't necessary, and I didn't realize the need for the reinforced section was only because we were using extremely antiquated methods. But anyway, with the heat treating of today, it's not necessary, and it doesn't, we've done a lot of things. People tend to think it has something to do with feel. People tend to think a reinforced tip's going to go lower. And we've done so many tests that it doesn't go lower. And I can guarantee you that. And it may affect feel. People feel so tough, Some guys can feel things that hardly exist, and other guys can't feel anything.
Yeah.
Yeah, we get that in feel. Tour players too, and some guys can feel everything. And some guys, no feel at all. Just hit it.
And some guys really do feel everything. There are some guys out there that just.
Then you get the guys over top that feel stuff that doesn't exist, and then you really lose your mind, right?
Yeah.
So.
And we've all worked with those.
Yeah. And then we're trying to measure it. Even weirder.
Yeah.
Those are the guys in the tour trucks. When they come in the tour truck, everybody seems to go this way.
Disappears.
Yeah. People get busy.
No, it's 6'1". I think it should needs to be 6'0". Maybe 6'1.0" or something.
Yeah. Yeah. Designing golf shafts. You actually, Mark touched on this more than Kim. You talked about trimming from the butt end and trimming from the tip end, and I know you and I had a conversation a while back, Kim, about R300 and X100. Like the original difference was how they trimmed the same material.
Yeah. Okay. Here's what. Can we explain that?
Yeah. Go ahead.
Yeah, go for it.
Okay. So an S and an X, they weighed the same. And what they would do is they would take the exact same blank and move it 2 inches one way or 2 inches the other, depending on if it was going to be an S or an X. And I mean, it's brilliant from a manufacturing standpoint. All you have to do is make one. It's just brilliant.
One tube, and you just trim it.
For either side.
Yeah. So you want to kill as many birds as. The manufacturing people want to do things to get stuff through, and that was brilliant. Anyway, so that was the difference between an R and an S back in the 50s. It was simply it was the same tube. It was just trimmed differently depending on.
Would that have affected weight though?
No, the butt and the tip, if it's reinforced, there's a little bit of difference. But if you get away from the reinforced area, they're almost identical, because what happens as the size increases, the wall decreases. And it's almost a one-to-one relationship when you get done doing it.
Yeah. So essentially, I'm sure Kim will correct me if I'm wrong on anything, by the way. But essentially, what they do is they start off with a tube. They make just a tube, right? So if you forget about the reinforced part or whatever, you got this tube, and you hammer it down, right, to make it smaller, and so the tip part is a thinner diameter, and the butt gets thicker. Well, the tip, as you bring the diameter down, it makes it more flexible. Versus, the diameter makes a bigger difference than the wall thickness. So by crushing the tip, because the diameter is thinner, that part's softer. So if you think about a blank, if you've got, 600 on this side and 335 on this side, and you taper it down all the way. Where you cut that thing it depends on how stiff it is. So your step pattern, right? So
Yeah.
the difference between an S and an X was the step pattern started 2 inches lower.
Yeah.
And that's really all there was to it. So it was years later that we started making overall blanks are lighter, so that you're doing different things to begin with, and that's how it kind of progressed.
Yeah.
But yeah, all the tubes were the same.
And obviously graphite is so different, so many
Yeah.
different materials out there. Is there anything we can touch on graphite that would be really interesting for somebody listening here that wants to know about golf shaft production that you just can't find out there?
Well, you know, other than drivers, being able to make a golf club really long, which is, you know, the initial, you know, one of the initial reasons why graphite became so popular.
Right. Weight.
Yeah, it was the weight. And with graphite, you simply, once you get below it all depends on how much force you put on it. If you don't load it you know, that much, it just may not necessarily apply. But you get to maybe 110 grams with a person that can, you know, move it fairly good. The shaft becomes unstable. And in steel, there's nothing that we can do to make it stable and without making it really feel bad in order to maintain that stability.
Yeah, you're actually got to make it heavier.
Make it heavier or blow it up, and then it doesn't feel as good. So,
what does the OD do to feel? Why does a larger OD impact feel?
well, OD's the #1 contributing factor to stiffness in a steel shaft.
Yeah. So it jars. It is a more jarring feel when it's
Yes.
larger OD for a longer period of time.
What it seems to feel like, what we've kind of come up with when we really blow up lightweight shafts, which is what we did with the precision
Rifle
light, rifle light,
Yep.
light.
A couple of guys like that.
Oh,
That's it.
I mean,
Tim
if you-
Herron, I think, was one.
Yeah,
And
if
that was about
if
it.
you wanted a shaft that stayed still, it stayed still. That shaft didn't move very much.
It's a big diameter, right? So a thick shaft. So
Yeah.
that's how they're trying to make it lighter. They just use a lighter tube, thinner walls,
Yeah.
and make the diameter bigger.
Larger.
Yeah, when I say
learned-
blow it up,
And we kind of learned at
Yeah,
that point
yeah,
that
yeah.
they don't feel good.
yes, and that was when that's when we learned, even though it has a good pattern and all those things, that it just didn't feel good.
So any insight there onto like the fat shaft, you know, the Wilson fat shaft or the bubble? That's obviously a similar kind of thing. So the bubble had, the TaylorMade was a large OD
Yeah.
in the middle there.
That was a whole different animal, kind of that's graphite, and that was mostly marketing.
It was
to be
my
honest.
mostly.
you know, all marketing.
I
yeah.
think it was all marketing.
Yeah. Now the fat shaft on the tip that made some sense, right? So you made that diameter bigger,
Yep,
so you
yep.
made it more stable, so you can make it softer
And cheaper.
Yeah, and cheaper. Yeah, way cheaper, right? Because you don't have to pound down as far. Right?
And you can have torque and stiffness without using so much material.
Right.
A couple of questions I always get asked by people, like if they're transitioning from steel to graphite, and often, you know, it's an elderly gentleman or a lady, is about like perishability of graphite. Was that a thing? Is that a thing?
I would say this, and what I've told people, I mean, graphite, from what I've seen, is either straight or it's broken. I mean, once the fibers start breaking, it's gone. It's going to break at some point. So you don't see a bent graphite shaft ever, right? No. I don't know about breaking down over time. I haven't
resin,
really
does
seen
the
that.
resin
While
ever-
the resin's glued, it's solid. Once that breaks, they typically break pretty quickly, so they don't really wear down.
No,
If you put the frequency in a shaft and measure, you know,
It's-
hit
it's-
4,000 million shots and then measure it again, it's going to be the same.
Yeah.
Unless it breaks. Steel can
essentially.
bend, and does it work right at all?
Well, what happens with steel shafts is when people are pulling them out of the bag, they may kink them, and that leads to a weak spot, which can lead to some a shaft breaking. But that had nothing to do about the shaft getting older.
Yeah.
It was damaged in some other way, which caused it to break. You know, bounced against. You know, there's so many things that can happen that can deform the shaft that causes it to break. But you know, steel or graphite, you know, as long as you take relatively good care of them, they don't break down.
Okay, and another one, which is often followed by the first one, is consistency. So people say, I'm in steel, and graphite's less consistent than steel. And I'm not talking about
that used to be the case big time.
right, and I'm talking about from shot to shot, not necessarily
It's not
flex to
like
flex.
Graphite shafts only have stiffness in the direction that they're laid up in, and to be able to lay up shafts exactly the same time after time after time after time is not going to happen.
No.
So I mean, there's an inherent just because of the material, there's an inherent advantage to steel because, again, it's homogeneous. It has strength in all directions in terms of consistency.
So even with today's high-end materials, you would say that there would still be possibly some outliers with graphite iron shafts.
Now, graphite has gotten a lot better. I mean, a million years ago when we started, doing graphite, I mean, I remember the first shaft that was popular, graphite on tour, that we did some of was G. Loomis, for instance, right? It had a really thin top and the bottom was super thick graphite. They just piled it up so they get the swing weight close. And they were all over the map. And you put on a frequency thing, you're be 5.0 and it may go to 7.0 to 6.0 and up and down all over the place. And that was the case with all graphites for a long time. But they have gotten over the years considerably better at it. So the whole thing with when you started FM Precision, to some extent, is Dad's concept. It was to match a set of irons and get them all to feel the same. And the steel, that's not that difficult. Frequency matching them, you get them all the same, the weight and everything. Graphite, that was very difficult. But the processes have gotten so much better that, look at the ladies store right now. They're all playing graphite. And it's even starting to sneak onto the men's store. The reason it's not more of it on the men's store really is, they need the weight. They got enough power that, 125, 130 grams is not a bad thing. And they don't need distance.
Yeah.
The rest of us do, right? Maybe not you, but, we're building a little older, so we can use all the distance we can get. So lighter makes sense.
Yeah. So I'm just going to keep rolling while I've got it in my head. Many people, and I'm talking about club fitters and manufacturers over the years that I've been in the industry, have talked about like wall thicknesses in the tips, and so they've cut out, dissected a golf shaft and then looked just at the tip of a golf shaft and said, "Oh, this is a poor quality golf shaft. It's got a lot of carbon, a lot of graphite in the tip."
You remember when you cut it and look under a microscope? I actually saw that at your dad's office the first time. When you had the cut out of the shaft and you had it zoomed in with a microscope and you could see the imperfections So there's a question about that. And years ago, people talk about seamless shafts and stuff. Fill me in on that a little bit.
I don't even remember what picture you were talking about.
You had a microscope and you were checking the configuration, the weld in the shafts.
I thought you were talking about we had a picture of something.
No. You would actually cut the shafts and you'd actually your microscope in and look at the
this. I'll talk about something else, but the weld. There really isn't a weld on a golf shaft. When you weld something, you're actually introducing a foreign material. What happens with golf shafts? This is a frequency thing. What you do is, and I know this wasn't asked, but this is a question that comes up.
Cool stuff.
Here's what happens. You excite both ends of the stock. Almost all golf shafts, steel golf shafts, start with on a coil.
Yeah, it's basically a sheet of, basically 3-inch, 4-inch wide.
Yeah, I believe it was 3.5, but whatever it is, 3 or 4 inch wide steel, and it's in a coil, and these are flat. So you start forming these things, and as you form them, you start forming it into a tube. And then what happens is it's a high frequency induction coil. And what happens is both sides of the material, both sides of the steel are excited, and they just blend into each other.
Right.
And
so there's no joint.
It's impossible.
No real seam.
It's metallurgically impossible after it goes through the heat treating, the next heat treating. Yeah. Now, at this point, you certainly could find it. But after it goes through the first heat treating, you're not going to be able to find where this thing is. People have often thought that, when they're doing things like with puring, they're messing around with the weld. They're not. They're not. What they're messing around with is the straightness of the shaft.
That's the biggest issue, right?
The shaft is going to tend to want to these things, arrows are straight. Golf shafts are not quite as straight. I mean, it's impossible. They're damn straight, but they're not nowhere near as straight as, let's say, an arrow. So what happens in that case is it has to do with either the roundness of the shaft or most often the straightness of the shaft. Whichever way the shaft is bent, that's the way the shaft wants to go. And so anyway, just to maybe straighten out something that a lot of people think. It's not the weld that they're finding when they're spinning a shaft.
No, it's a straightness.
It's straightness.
You've
spun it. You've spun shafts.
Oh man, how many shafts I put in a pure machine, and you see it rotate, and you're like, wow, that was a lot of a different shape around that circumference.
Well, the more dominant it is, the more easily it goes in that spot, the more crooked the shaft is.
So that whole process you're talking about would be still considered the spine. You know, like when people talked about spine, was that what they're seeing? That where the most straight, you know, the hard line is?
The hard line
There's
is
no definition of any of that.
Yeah,
So.
yeah. Well, yeah. I don't know what a spine is, but I think originally they thought they were talking about welds.
Yeah.
But whichever direction this shaft is bent in predominantly, they're not only bent in one area. They're okay. Whichever way it's predominantly bent in, that is going to be the stiffest section. Whichever the direction towards.
And that's what we noticed on our S3 machine too, because we separate materials from straightness, right? So straightness, you can have a perfectly straight shaft, and in steel you're going to have a really good shaft because as long as your wall thickness is the same material. In graphite, you can have a really straight shaft, but the materials aren't laid up correctly, like you was talking about the 45s and 90s, and then it wobbles all over the place. So you're going to need two things you're looking at: is material quality as far as consistency, and then straightness, and both of those play an effect. And you know, in steel, it's mostly straightness that makes it not symmetrical. In graphite, it's a lot of materials. It's way more difficult.
So the only way we have of measuring consistency of graphite right now, outside of its straightness, is measuring batches of golf shafts.
Yeah.
Outside of destroying a golf shaft and
Yeah.
taking that as a given that all 20 of them are going to be like that.
Yeah, and that's what we go through, is we try and look in graphite for ones that are relatively consistent. We don't carry them, because if they're not consistent, then you get one and it's a demo and you hit that, and you try this other one you build and they're totally different, and that's a different shaft. So part of our process on what shafts we carry is looking for ones that are consistent to begin with.
Yeah.
And there's a lot of good ones out there. There's also a lot of bad ones.
Yeah, and with you guys frequency, you match the stuff that you're making. If you're not going to, it's going to take you a lot more time and effort if you don't have a good set of shafts when you're.
Oh yeah, right.
Well, that's a big thing of our builders go through.
Yeah,
and why
it takes a long time to build clubs.
They've got to go and select a consistent batch of golf shafts, and then they're trimming them consistently, and it takes time. It's not.
Just glue them in.
Yeah, it's not a manufacturing product. It's not just an input output. They actually have to do some work on it. Yeah. But you're a good guy to ask this, and I'm sure it's not going to tread on anyone's toes. Is an SST PURE, which we use here and is used around the world, most custom manufacturers. A lot of people, especially even clients, have said this to me of like, okay, well, isn't SST PURE saying that the shaft manufacturers are doing a bad job? What's your answer to that? You're a shaft manufacturer.
I think that machine is definitely in a way a quality machine.
It is. It's a quality control machine as much as anything.
And it does. It's going to pick out things that are. You use the machine a lot more than I do, but things like crooked. It's going to pick out the outliers.
Oh, yeah.
Yep. The thing, I've done a lot of testing. I know Dick Weiss really well, and
Dick Weiss, the owner, designer,
the guy that designed it initially. And I'm going back some time now, and when I was actually with Brunswick, Dick would, he wanted to, he wanted to work with a large shaft manufacturer, and Dick, he's very passionate about what he's doing, and he believes 100% in that machine.
Yep.
And
I believe it does something.
I believe it does something too. And when we did our testing and blind testing, this was at Goff Smith, and Dick was involved. He picked me up, and we had all the testers and what have you. We generally got around 55%. So maybe there is something. Maybe there is something.
Well, the only proof I can come up with, and it's actual number I can quantify, is back when we did hot sticks technologies and stuff, and we used to, and we still do now. We measure all the shafts with a robot, and if the shaft was pured, it took an average of like 5 swings down the robot. If it wasn't pured, it would take an average of 7 swings. And that was pretty consistent, over time. So it's supposed to be something. Now, what does it say? I don't really know exactly how much, but I will tell you, the worse the shaft is, the more important it is to pure it, get it lined up.
Yeah.
So theoretically, if you got perfect shafts, you wouldn't need a pure machine. But they don't exist. It's like a unicorn.
There's 2 really interesting points you made there. One is the fact that even a robot swinging what we would consider as identical, I know it's not exactly identical, but it's as damn close as we can manufacture. SST PURE has some effect. So it should then have an effect for an inconsistent golfer, maybe even more.
The question is not whether it has an effect or not. I think we all kind of agree it does have some effect. The question is how much.
Yeah.
And all I can tell you is I think that it's a lot more effective with bad shafts, and they do exist. So it's almost like a guarantee, right? So if you got a bad shaft in a batch, now we try to make sure we don't carry them to begin with because we sort through and S3 and test all the stuff, so we carry the best products available, most consistent products. But if you got a bad shaft, that might actually make it a good shaft.
And the thing is,
better maybe.
Yeah, better.
An SST Pure, it's not like we get a KBS for a guy and the Pure machine tells us, no, that's wrong, don't use that. It just aligns that with one product that we're going to use anyway in the best possible form. So it's just helping. It's doing nothing but help.
I think we're all agreeing. It certainly can't hurt, and it might help. So and take all the variables out.
Yes, yeah, and to think that you're just bending one axis of the shaft, you're not. You're bending around the entire circumference during the swing.
Yeah.
And by orienting the shaft differently, there's no question in graphite that there has been situations where it plays differently.
Oh, yeah.
So that's one thing that this machine definitely is taken out of. The outliers.
It's a great quality control thing. If you get some really bad shafts on there, you don't want to sell them. So.
Yeah. You've exhausted. That's all I got. I haven't got any more shaft questions in me today, at the very least.
Okay.
So thank you so much, guys. That was brilliant. I think guys are going to love that. There's some stuff there that I don't think is out on the web. So thank you so much.
You.
We'll see you again.
Enjoyed it.
See ya.
Cheers.
Bye.